Okay, in this lesson we're going to take a look at angles that are on the outside of the circle instead of the inside of the circle. And again, for every one of these screencasts, I encourage you to do it on your own, and you'll learn the lesson a lot better than if you just watch the screencast. So open up that GeoGebra and follow along as you see this tutorial. Okay, in this example, we're going to go ahead and create a circle with a center and a radius, and we'll use a radius of 4 units. That should be fine. Okay, and then what we'll do is we will create a point that is outside of the circle, not on the circumference. So I think I want to get rid of that one. And we will create a point somewhere out here, let's say. And our goal is we're going to try to create an angle that's sitting out here and it's going to pass through the circle. If it passes through 2 points, then that's called a secant. So let's go ahead and make that random point. I'll put it out here somewhere. And now what we're going to do is we are going to create a point on the circumference, here let's say, and then we'll create another point, let's say down here. And what we're going to do is we're going to create 2 secants. And secant just is a point that passes through the circumference in 2 different places. So we'll go ahead and make a ray tool. And this will be the beginning of the ray, and it'll pass through point C. So you can see that the secant passes through these 2 points right here. And then we'll take a second ray, starting at the same point, and this time it'll pass through point D. And this is how we create an angle on the outside of the circle. Notice the lines are not very special other than being secants. They're not tangents, they're not inscribed angles, they're not central angles, the angles are not on the inside. So in this example, we're interested in finding how big B is. What is angle B in degrees? So we're going to go through the same process we did when the angle was on the inside. This time it's on the outside. So let's go ahead and measure B. Let's actually find out what it is. And the problems you'll actually have to solve for B will be unknown to you. And in this problem it's 37.8 degrees. Now we have to figure out, just like the last lesson, that where the intercepted arcs were involved in figuring out the inside angle. Same situation here. We're going to use this arc right here and this arc over here to figure out how big this angle is, the 37.8, to confirm its size. So we'll use 2 more points, and I'll use the intersection tool. I'll highlight the circle and then the arc. Actually, I don't want to do that. I just want to get that 1 point. So I'll just plot the point right where I want it. Right here. I already have the other points. Okay. And so we need those 2 points to measure that minor arc right there. So if you recall, the way we're going to measure the opening of the arc is by using the central angle. The arc measure and the central angle are the same. So let's go ahead and create those segments. The radius. Here's a radius from A to C, and again it's dashed, that's good, and another one here, and then we'll do the same thing going to the other arc like that. Alright, now we'll go ahead and measure those angles, those arcs, central angles, and let's see what we get here. Forgot to go clockwise. About 51.7, and then so that would be this arc measure matches the central angle, and then we'll do the same thing with the other arc. We'll go ahead and measure that angle, and that arc measure is about 127.2. Let's see if I can drag it over there. That one more time. I'm going to measure the angle. There we go. And then I was just trying to drag that 127 out so you can see it better, but I'm having trouble with it. There it is. Okay. And again, I'm going to hide the dashed lines just to make it cleaner here. And I'll do that by holding down the Control key, selecting all the radii. Control G will hide them. I want to leave these angle measures because then it'll just point to those arcs that I'm interested in. So this 50.6 represents this arc measure right here, and the 127 represents this arc measure right here on the outside. So here we go. The connection between these two arcs and that angle on the outside is, instead of adding the two arcs, you guessed it, you're going to subtract the two arcs, divide by 2. So let's make sure that works. We'll get a calculator here. Clear out the calculator. So one of the arcs is 127.2 degrees, and we will subtract the smaller one from the bigger one. So the smaller one is 50.6 degrees. We'll get that difference, and then we'll divide that by 2, and if everything goes well, the nth 3 according to the calculator, 38.3 according to GeoGebra. So it does work. So if you were to change the arcs, bigger or smaller, that relationship would still hold up. You would take 90.2 minus 33.3, divide by 2. It should match the outside angle. And again, if you're missing one of these arc measures, let's say they gave you this one, but they didn't give you this one, you would set up an equation. You would take the 90.2 minus the unknown arc, divide by 2, and it'll equal the outside angle. So that's going to be the short lesson here. It's very similar to the other lesson. The only difference is you subtract when it's on the outside, you add when it's on the inside.